Hello everyone, welcome to today's presentation. This video is about matrices. The question is, given A, B and C as matrices shown below, so we have them there. Determine matrix D given by D is equal to AC minus B, hence its inverse. So from this equation, D is equal to AC minus B. We are going to multiply matrix A by matrix C in that order, and then subtract matrix B. So our task here is to substitute and carry out the operations as instructed. So we have matrix A as 2, 3, negative 5, 0. And then it multiplies matrix C, and C is 1, negative 4, 5, 1. After that, we will subtract matrix B, and matrix B is 3, negative 1, 4, 2. Now coming to the part of multiplication, we need to recall that when multiplying, we multiply row by column. So we begin with the first row of the first matrix and multiply by every column of the second matrix. So 2 by 1 is 2, 3 by 5 is 15, 2 plus 15 is 17. So we are going to have 17 here. Again, row by column, 2 by negative 4 is negative 8, 3 by 1 is 3, and therefore negative 8 plus 3 is negative 5. Applying the same to the second row of the first column, negative 5 by 1 is negative 5, 0 by 5 is 0, add, we get negative 5. Negative 5 by negative 4 is positive 20, 0 times 1 is 0, add, we get positive 20. And then we subtract B, B is 3, negative 1, 4, 2. From here, we are going to subtract the corresponding elements. Now 17 corresponds to 3, negative 5 corresponds to negative 1, negative 5 corresponds to 4, and so on. So subtracting, we have 17 minus 3, that should give us 14. Negative 5 minus negative 1, that should give us negative 5 minus minus 1, that is negative 5 plus 1, which is negative 4. So here we have negative 4. And then negative 5 minus 4, that is negative 9. 20 minus 2, that is 18. So matrix D determined is 14, negative 4, negative 9, 18. The next thing is to determine its inverse. Remember, we're told the moment we've obtained D, we need to find its inverse. The inverse of matrix D is obtained as 1 over the determinant of matrix D into, so the matrix that we have here is one such that the elements of the leading diagonal are interchanged. So 18 will take up the place of 14, and likewise 14 takes up the place of 18. And then for the second diagonal, we are going to negate them. So we negate the elements. So negative 9 becomes 9, negative 4 becomes 4. The remaining task here is to determine the determinant of D. So we come back to matrix D, 14, negative 4, negative 9, 18. We are going to get the difference between the product of elements in the leading diagonal, that is 14 times 18, and the product of the elements in the second diagonal, that is negative 9 by negative 4. Well, if we multiply 14 by 18, we should be getting 252. And then we subtract negative 9 by negative 4 is 36. This is 216. Well, with the determinant of D, we are going to determine the inverse of D as 1 over determinant, which is 216 as obtained. And then we have the matrix 18, 4, 9, 14. Well, we'll have to multiply 1 over 216 by every element inside. So we have 1 over 216 times 18. Now that simplifies to 1 over 12. Again, 1 over 216 times 4, 1 over 54. And 1 over 216 times 9 is 1 over 24. And finally, 1 over 216 times 14 is 7 over 108. And this is the inverse of D as desired in the question. And with this, we come to the end of the solution to this problem. Thank you for watching. Thank you for staying with me till this end. Hope to see you on the next one.